Welcome to the another session of high-speed hydrology course. So, last class we discussed about transpiration and evapotranspiration, and we started even infiltration as well. Okay. So, infiltration, we've been discussing about Horton's infiltration capacity curve, right? That's where we stopped. Okay. So before we start, this Unacademy offering 23% discount on all subscriptions. క్లాస్ చెప్తున్నా నేను. So, Unacademy is conducting mock examinations on all streams, free of cost. You can enroll. Use my code GATE Civil. Okay, let us continue our discussion with respect to Horton's infiltration capacity curve. So using Horton's curve, I can measure both infiltration and as well as runoff. If infiltration is given, runoff is expected to work out. If runoff is given, infiltration is expected to work out. How to find out? By superimposing rainfall Horton's infiltration capacity curve over rainfall hydrograph along with the infiltration, we can also work out runoff component. So this portion of hydrograph lying above Horton's curve is runoff. This is. So below this portion, this green color hash is called infiltration. This is infiltration. This one is runoff. Okay. So area of hydrograph above Horton's curve is runoff. Area of hydrograph below Horton's curve is infiltration. But that is not always correct. But sometimes I is less than, I is greater than FC. It is okay. If I is less than FC, then FA is equal to what? I only. When I is greater than FC, FA is equal to FC. When FA is equal to FC, area below Horton's curve will give infiltration. If I is less than FC, FA is equal to I. Therefore, area below Horton's curve is overestimation of infiltration. Therefore, carefully need to estimate because FA is equal to I there. Okay. Horton approach is correct only for condition, only for terms I is greater than or equal to FC. So it's then only you can apply Horton's approach. Understood? This point you have to keep in your mind before you solve questions. Let us solve one example. You realize how difficult it is to apply Horton's approach to find out infiltration and as well as runoff component. So yesterday we solved two numericals. So let us try to solve one more numerical related to Horton's approach. Example 1. This is during this is a GATE question, 3 hours term, GATE 2006 this is. During a 3 hours term, it was observed that all abstractions other than infiltration are negligible. The rainfall was idealized. Three 1 hour storms of intensity versus time will give hydrograph. Hydrograph information is given 10 mm per hour, 20 mm per hour and 10 mm per hour respectively. And infiltration was idealized as Horton's curve. F is equal to 6.8 plus 8.7 e power minus t, where F is in mm per hour and t in hours. What is effective rainfall? So what is asking? Effective rainfall means what? Runoff. And he has given options. A 10 mm, B 11.3 mm, 33 mm, C 12.43 mm, D 13.63 mm. So like this 4 options are given. One is correct option. You have to pick up the correct option. So what he has given? 2 things are given. Rainfall information is given in the form of hydrograph and infiltration information is given in the form of Horton's curve. So using rainfall and infiltration can't work out runoff. Effective rainfall is nothing but runoff. Runoff is equal to rainfall minus infiltration. He is asking effective rainfall. Effective rainfall is nothing but runoff. So runoff is equal to what? It is rainfall minus infiltration. This will give runoff. Okay. To find out rainfall, what is given? Rainfall hydrograph is given. In the form of rainfall. Rainfall information is given in the form of rainfall hydrograph. 0 to 1 hour 10 mm per hour. 1 to 2 hours 20 mm per hour. Again it is 2 to 3 hours 10 mm per hour. So 10, 20, 10. Intensity versus time plot. Mm per hour. This is time. First 1 hour, second 1 hour, third 1 hour. Similarly, infiltration information to work out what is given. Horton's curve is given. Horton's curve is given to find out infiltration information. What is Horton's curve? Infiltration capacity versus time plot. So that is given as in the form of equation. So this curve is represented by, we took it as FCT is equal to F is equal to 6.8 plus 8.7 e power minus t. So different time intervals you can find out. Infiltration at 0 time, infiltration after 1 hour, infiltration after 2 hours, infiltration after 3 hours. You can work out. In 3 hours total rainfall is area of hydrograph. In 3 hours total infiltration, it is area below hydrograph or area, or if it is I is greater than equal to FC everywhere, area below Horton's curve will give infiltration. Okay. So I have to superimpose these two and I have to work out. So before I superimpose, I need to work out at FC1. What is this? Is this FC1? FC0. This is FC0. This is FC1, FC2, FC3. This is FC1 after 1 hour. This is FC2, FC3. This is FC0, FC0, FC1, FC2, FC3. I will work out. So if I substitute T is equal to 0, I will get FC0. If I substitute T is equal to 1, I will get FC1. If I substitute T is equal to 2, I will get FC2. If I substitute T is equal to 3, I will get FC3. So everywhere I values are more than FC values, Horton approach is true, then you can work out. So if I work out into time t in hours, and FC values, FCT, it is 6.8 plus 8.7 into e power minus t. So after 1 hour, 0 hour, at time t is equal to 0, so FC naught is equal to, substitute and find out. T is equal to 0 means what? This whole thing will become 1. E power minus 0 is 1. So it's 6.8 plus 8.7, it is 15.5 mm per hour this is. Okay? FC1, if you substitute 1 here, e power minus 1. Come on, work out. Substitute 1 and find out. If you substitute 1, it is, in that equation, e power minus 1 into 8.7 plus 6.8, it is 10. Substitute 2 in that equation. So e power minus 2 into 8.7 plus 6.8, it is 7.97. FC2 is 7.97, and FC3, substitute 3 in that equation, e power minus 3 into 8.7 plus 6.8, so it is 7.23. So we got values, FC values at different. So if I superimpose now Horton's curve over rainfall hydrograph, so this is 10 mm per hour, 0 to 1, 0 to 1, 10 mm per hour, and 1 to 2, 20 mm per hour, 2 to 3, again 10 mm per hour. So FC values I substitute, it started 15.5, this is 10, 20, 10, but it started 15.5, somewhere here, 15.5 this is, FC naught. Exactly after 1 hour it is 10, after 2 hours it is 7.97, somewhere here, after 3 hours it is 7.23, and if we join all these points, we get Horton's curve. This is Horton's curve. So in this portion you see, in this portion first 0 to 1 hour, so I values are less than FC, FCT at that time. Therefore I value is less than FC, so in this time period, FA is equal to I. So rate of rainfall is equal to rate of infiltration. Between 1 hour to 3 hour, I values are more than FCT, Horton approach is true. So in this portion, 1 hour to 3 hour, FA value is equal to FC only, FCT only. So therefore, first 1 hour Horton approach has failed. So first 1 hour rate of rainfall, rate of infiltration is same. This is infiltration. This is infiltration. The green portion is infiltration. Blindly if you take area under hydrograph, area of hydrograph below Horton's curve if you take, you will get wrong. So this is infiltration. Then where is runoff? This is runoff. This is runoff component. So you have been asked to find out this runoff component. Therefore, rainfall anybody can find out. Area of hydrograph is rainfall. So rainfall is equal to, it is area of hydrograph. Total area of hydrograph is equal to sigma I into sigma I into T, II into T. So which is equal to, so rainfall is equal to first 1 hour, intensity is 1, time is 1. Second 1 hour, intensity is 20, 1 hour. Third 1 hour, intensity is 10. So total rainfall is in 3 hours is 40 mm. Then infiltration. In first 1 hour, rate of rainfall, rate of infiltration is same, 10 into 1 plus remaining 1 hour to 3 hour, Horton approach is correct. Therefore, I can integrate 1 hour to 3 hours. I can integrate to find out infiltration. So which is equal to 10 plus, if you integrate with these values, what we will get? 6.8 into T, 1 to 3 plus 8.7 minus 1 e power minus T, 1 to 3. This is integration. So 10 plus 6.8 into 3 minus 1 minus 8.7 into e power minus 3 minus e power minus 1. Simplify, we will get to infiltration. So e power minus 3 minus e power minus 1 into 8.7 into minus 1 plus 6.8 into 2 plus 10. So it is 26.367. So therefore, effective rainfall is in 3 hours is equal to, so effective rainfall in 3 hours is equal to, that means runoff in 3 hours. So rainfall in 3 hours minus infiltration in 3 hours. So rainfall in 3 hours is 40. Infiltration in 3 hours is how much we got? 26.367. So 40 minus 26.367, how much it is? 13.632. 13.633 actually mm. That much we got. What options given there are? What options are given in the question? 13.63 is there. So you can go with this option. This is the right answer. So blindly work out, you will go wrong. You should be careful. So wherever Horton approach fails, their rate of rainfall, rate of infiltration is one and same. Because whenever I is less than FC, then FCT otherwise. FA is equal to I. I is greater than or equal to FCT. FA is equal to FC. Horton approach is true only for this. Horton approach fails. So rate of rainfall. This is a rate of infiltration. FA is actual rate of infiltration. Sometimes actual rate of infiltration is intensity of rainfall. Sometimes actual rate of infiltration is infiltration capacity. So that is where you're supposed to be careful. This kind of confusion is there with Horton's approach. To overcome this confusion, for our comfort and convenience, right, we have developed the equivalent procedure called infiltration indices. Understood? Infiltration indices concept came to overcome this confusion. What is that confusion? Sometimes rate of rainfall is equal to rate of infiltration. Sometimes rate of infiltration is equal to rate of rainfall. Sometimes rate of infiltration is equal to infiltration capacity. Sometimes it is same, sometimes it is different. Okay? So next topic is what very important topic, that's also infiltration indices. So infiltration indices represent infiltration at an average rate. That is average rate of infiltration. But here also two indices are there. You should be careful regarding using them. There are two types of infiltration indices. One is called pi index, other one is called W index. These two are called infiltration indices. Both of them are equally important. What is pi index? What is W index? You're supposed to have idea regarding them. So pi index is defined as the average rate of infiltration during that portion of a rain producing runoff. So whenever runoff is there during that period of a storm, whatever rate water infiltrate into ground is called pi index. So whether runoff is there or not, no matter, during the entire storm duration, the average rate of infiltration is represented by W index. So pi index is defined as What is pi index? Pi index is defined as average rate of infiltration during that period of a storm producing runoff. When runoff component is there, there is no pi index exist. When runoff is there, then there is pi index exist. So wherever, whichever portion runoff component is there during the storm, during that period only there is a pi index. Remaining portion, there is no pi index. So how we can define it as pi index is equal to infiltration during the period of a storm producing runoff period of a storm during the runoff period, otherwise during the runoff period of a storm. During the runoff period of a storm. By, so duration of runoff, how long runoff is produced. So storm duration during runoff. So if you take this, you will get average rate of infiltration. So runoff is equal to what? Infiltration is equal to what? So it is rainfall minus runoff. So since infiltration is equal to, it is rainfall minus runoff. So we'll do like that. Okay. So I'll take letter PE is the rainfall during the period of a storm producing runoff. I am taking one symbol. During the runoff period, so rainfall is PE and TE is equal to duration of storm duration during the period of runoff. Storm duration during runoff period. I am just taking some symbols so that we can put into mathematical form, equation form. And R is equal to runoff, let us assume. Therefore, this pi index we can take it as infiltration is rainfall minus runoff by duration of storm, PE minus R by T. So just by using this equation, we can work out pi index. Pi index is equal to PE minus R by T. Okay. Next one is W index. So double index is defined as average rate of infiltration during the entire storm period. During the entire storm period. So whether it produces runoff or no runoff, no matter, you can take it. Let P is equal to, it is rainfall, total rainfall during storm, and T is equal to total storm duration, and R is equal to runoff. Therefore, this double index is equal to, it is infiltration, total infiltration by storm duration. Total storm duration. So therefore, this double index is taken as, mathematically if you write in the form of equation, it is P minus R minus, there are some losses also, the initial losses, they also taken into account by T. Why initial losses are not taken into account in pi index calculation? After meeting all initial losses only runoff is produced, because so P minus losses are not taken into account in calculation of W index, pi index. The reason is because runoff is produced after meeting all losses. So we are taking only that part of rain producing runoff. Therefore, after meeting loss only runoff is produced. Therefore, it is not taken into account. But in this case, initial loss also taken into account. The interception loss and all, though they are small. If they give, we'll take. If not given, we'll take losses as 0. If losses are given, they are taken in double index calculation, but not taken in pi index calculation. Pi index calculation, we don't take losses because runoff is produced only after meeting the losses. So we are taking only that part of rain producing runoff. Therefore, that is not taken into account. If losses are not given, then losses are taken as, initial losses are taken as 0. Remember that. This much idea is there, comfortably you can work out. Okay? So procedure to find pi index and double index. Let us see how to work out pi index and double index. Usually catchments receive two types of rains. One is uniform rain, the other one is non-uniform rain. Uniform rain is the one which rain with the same intensity during the entire storm duration. Non-uniform rain is the one whose intensity keep on changes from time to time. So it slowly start, at some point of time it rain with very high intensity and slowly it stop and disappear. But whereas uniform storms are not like that. So they rain with the same intensity throughout the storm. Okay? So for uniform storms, normally uniform storms occur for a short period of time. So for uniform storms, case 1, uniform storm means what? During entire storm duration, intensity is constant. Rainfall intensity is same. Rain occurs with same intensity throughout the storm. For uniform storm, so they rain with very high intensity. So if you superimpose that pi index line over rainfall, that hydrograph, this is a pi index line. This is pi value. This is pi index line. Average rate of infiltration. Okay? So this portion is called runoff component. This is runoff only. The bottommost portion is called infiltration. This is infiltration. So for uniform storms, so P is equal to PE because it produces runoff right from the beginning of the storm to end of the storm. Right from the first drop of rain to last drop of rain, you can notice a runoff component in a catchment. Therefore, for uniform storms, P and PE, both of them are same. P is equal to PE, which is equal to I into T. This is T. Duration of storm is T, 0 to T hours it rain. Okay? And T is equal to TE. Assuming that losses are negligible, normally losses are very small compared to other things. Assuming losses are negligible, then if losses are negligible, then pi index is equal to double index, which is equal to PE minus R by TE. P is equal to PE, T is equal to TE. So both of them are one and same. So in the question, only one I value is given, only one T value is given. By default, we assume that it is a uniform storm. Many I values are given, many T values are given. By default, it is non-uniform storm. So for non-uniform storms, things are different. I value keep on changes from time to time. So non-uniform storm. So it rain with low intensity in the beginning. So at some point of time, intensity increases. Again, intensity decreases slowly and disappear. So what is this value? What is this value? This is I. This total is I, and this is pi. There is a meaning. Then what is this remaining? This is I minus pi. This I minus pi is there, then there is a runoff. This I minus pi into T is runoff. Okay, non-uniform storm. Understood, no? I'll show you when we talk about runoff. So there are many I values. This is I1, this is I2, I3, I4, this is T1, T2, T3, T4, something like that. So different time period. This is total storm duration. During the entire storm duration, this T is equal to T1 plus, T2 plus, T3 plus, T4. So for non-uniform storm, P is not equal to PE. P is different, P is different. So P is equal to area of hydrograph. P is not equal to PE. T is not equal to T. T is different, P is different. Therefore, pi index is not equal to double index. Pi index is different, double index is different. Usually, pi index is slightly greater than or equal to double index. Okay? So for such terms, what you need to do? How to find out pi index and double index? First work out, find PE. Find P first. How to find P? P is equal to, it is I1 into T1 plus I2 into T2 plus example I3 into T3 for that example, I4 into T4 and so on. What is T? T is equal to T1 plus T2 plus like this. Any number of T's are there. If you add them, you will get T. Find P and T. If any loss are there, they will give you. Then work out double index. Then double index is equal to P minus R minus losses by T. If losses are not given, we take 0. If we given, we can find out double index. Once double index is found, then with the help of double index, this double index if we superimpose, suppose double index line we got, this double index. So runoff component is, the thing above double index is runoff, or pi index and double index is runoff. This is runoff. So the values which are lying below double index, they never lie above pi index, because pi index is slightly more than double index. Therefore, I values which are less than double index, they don't produce any runoff. Therefore, they are neglected. So for finding pi index, what we do? To find PE and TE, neglect I values which are less than or equal to double index. So then find PE and TE values. So in this case, if you see, what is PE? So this is I2 is more than double index, I3 is more than double index. I1 and I4 are less than double index, they are neglected. Therefore, in this case, it is PE is equal to, it is I2 into T2 plus I3 into T3. And TE is equal to T2 plus T3, corresponding time period. So runoff is there from T2 time period, T3 time period. So that is only taken into account. Then we can find out pi index. Therefore, pi index is equal to this PE minus R by T. That's it. That's how we can work out. Understood? So what you need to notice is, you need to identify whether it is uniform storm or non-uniform storm. If it is uniform storm, pi index and double index, both of them are same. If it is non-uniform storm, pi index is different, double index is different. Slightly pi index, pi index will be slightly more than double index or equal to double index. Generally it is more than double index, greater than double index, not equal. Slightly, very, okay. Next, we can also work out runoff component using pi index and double index. Generally, using pi index, we can work out runoff component most of the times. For uniform storms, psi value is given to you and pi index also known to you. So superimpose that pi index line over I. This is pi index value. So this is total is I, and this is pi. This is pi. Then this value is I minus pi. Okay. That I minus I into T will give rainfall. Pi into T will give infiltration. I minus pi into T will give runoff only. So rainfall is equal to this I into T. Okay. Infiltration is equal to average rate of infiltration into time, pi into T. Therefore, runoff is equal to rainfall minus infiltration. So it is I into T minus pi into T. If I take T common, it is I minus pi into T. So what is the physical meaning of I minus pi into T? So runoff R is equal to, it is area of hydrograph above pi index. Area of hydrograph above pi index line. That area of hydrograph above pi index. So hydrograph lying above pi index is known as effective rainfall hydrograph. So area of hydrograph above pi index is known as effective rainfall hydrograph. Hydrograph lying above pi index is known as lying above pi index line is known as effective rainfall hydrograph. We call it as ERH. So runoff R is equal to area of ERH. Area of effective rainfall hydrograph will give, which is nothing but I minus pi into T. Okay, that's how we can work out. For uniform storms, it is so simple and so easy. For non-uniform storm also same concept, but you should be a little bit careful. For non-uniform storm, for example, you have got pi index line. This is pi index line. Then where is runoff? This is only runoff. This is runoff component. Okay? And these values are, this is I1, this is I2, this is I3, this is I4, this is T1, this is T2, T3, T4. So in this case, right, for non-uniform storm, runoff is equal to rainfall minus infiltration. What is that rainfall you have to take? Effective rainfall. So it is I2 into T2 plus I3 into T3 minus infiltration during that period. Runoff is nothing but effective rainfall only. Okay? Or area of effective rainfall hydrograph you can write. That hatched portion is area of effective rainfall hydrograph. Which is equal to I2 minus pi into T2 plus I3 minus pi into T3. So this into this. This I2 minus pi into T2. This I3 minus pi into T3. This I3 minus pi. This one is I2 minus pi. So that is effective rainfall hydrograph. This I2 minus pi, I3 minus pi. So we have to neglect. So R is equal to same area of effective rainfall hydrograph only, provided that condition. So you have to, while taking this, neglect those I values which are less than or equal to pi index. Neglect I values which are less than or equal to pi index. Only consider those I values which are above pi index to work it out area of effective rainfall hydrograph. Okay, that's all. Same concept, but only thing is that you should be cautious. You should not take all I values. Only those I values we take which are above lying, which are greater than pi index value. So I values, intensity of rainfall is more than average rate of infiltration. Only that portion of rain produce runoff. Only that is taken into account while working out runoff component. And rest of the intensities are neglected. Understood? So therefore otherwise, or you can also work out like this. Or find PE. PE is equal to sigma I into T only. So but neglect in this also I values which are less than or equal to double index or pi index. Okay, then T is equal to sigma T only. Again same thing. Then once you get this, then we know that pi index is equal to, it is P minus R by TE. So pi index is known. From this also you can find out runoff. So you know PE, TE, pi index, you can find out runoff. That way also you can work out. Okay, it is up to you. So whichever way you feel comfortable, you can use that procedure. So this is how we work out runoff infiltration with the help of this infiltration indices. Any doubt is there, you can ask me. Okay, then let us work out few examples, then things will be clear to you. Both GATE questions and other questions also will work out. So whenever we use this equation especially, I'll write one note. If you get R value negative, then so whenever you get R value negative means runoff is taken as 0. Okay, remember that point also. Now let us work out few examples you realize. in a particular season, a catchment was found to have a pi index of 0.5 centimeter per hour if the rainfall 2 centimeter occur in that season at a uniform rate. Uniform rate means what? Uniform rainfall in a 6-hour storm. The resulting direct runoff is options given: A -1 centimeter, B 0, C 5 centimeter, D 1 centimeter. Let work out. Come on, try this question. Let us see how to work it out. So what is given? Pi index is given. And he mentioned that uniform storm. And P is same, is given as 2 centimeter. T and T is same, it is given as 6 hours. And he is asking what? Runoff R. So pi index is equal to P minus R by T. So 0.5 is equal to 2 minus R by 6. So R is equal to, what is R value? -1 centimeter. So whenever you get negative runoff, what you need to do? Take it as 0. So 0 is the answer, not 1 centimeter. So 0 is the answer. Why it is 0? The reason being, if you work out I value for this, I is equal to what? P by T. So that is 2 by 6, 1/3. That is 0.33 centimeter per hour. 0.33 centimeter per hour. So this is I value. I value is 0.3 centimeter per hour in 6 hours storm. Whereas pi value is 0.5. This is 0.5 pi. This is pi index. So I value is less than pi index. This is I, that is pi. So since I value is less than pi, no runoff. Runoff is equal to 0. It doesn't produce any runoff. If I value greater than pi, then only runoff. Rainfall is more than infiltration, then only runoff. Rainfall is less than infiltration, there is no runoff. Simple as such. But this is how you need to work out actually. This is a logic. But nobody apply logic, simply substitute in formula -1 they get. So one option also there -1, they'll tick mark that option. That is wrong. So whenever you get negative runoff, that is taken as 0. 0 is the correct answer. So there is no negative runoff. Runoff never be negative, runoff is always positive. Okay? Let us take next question. Example 4. This is asked in ESE exam. This ESE question. The total observed runoff volume during a 4-hour storm with uniform intensity (2.8 centimeter per hour). Only one intensity is given, means by default it is uniform storm only. Is 25.2 into 10 power 6 meter cube from basin of 280 kilometer square area. What is the average infiltration rate? Average infiltration rate means what? Pi index or double index? For the basin. Basin means catchment. And he has given options. Like these options are given. So it is a uniform storm mentioned here. Uniform intensity throughout storm duration. Uniform storm. Okay. Therefore, P is equal to PE, which is equal to I into T. So I is given as 2.8 centimeter per hour. T is given as 4 hours. 4 hours storm it is. Therefore, P is equal to 2.8 into 4. It is 11.2 centimeter. Okay, that is right. T is equal to 4 hours. So average infiltration rate is equal to pi index or double index. Both of them same, no? For uniform storm. So it is pi index is equal to double index is equal to, it is PE minus R by TE. But runoff is not given. Runoff volume is given. So depth of runoff is equal to, it is volume of runoff by catchment area. This runoff is collected from an area 280 kilometers square. So runoff volume also given to you. So 25.2 into 10 power 6 meter cube from a catchment of area 280 kilometers square. 280 kilometer square you convert into meter square. So catchment area is given as 280 kilometer square. This you convert into meter square. So runoff volume. Volume of runoff collected from a catchment is 25.2 into 10 power 6 by 280. So we will get in meters. Come on, work out. .09 meters, which is nothing but 9 centimeter. Okay. So now you can work out average infiltration rate is equal to, I take it as pi index. So P is 11.2, runoff is 9, T is 4 hours. So 11.2 minus 9 by 4. So it is 0.55. We substituted centimeters, time in hours. So but answer is given in mm per hour. So which is equal to 5.5 mm per hour. That was the answer for this question. We can verify the given options. 5.5 is there or not? This is the right answer. Understood? So this is how we need to work out if question is given related to uniform storm. Okay, let us work out few questions related to non-uniform storms so that you will become expert. Okay. Let us solve one more question related to this one. Question number 5. This type of questions also they are asking related to uniform storms. The ESE question. A 4-hour storm had 4 centimeter of rainfall and the resulting direct runoff was 2 centimeters. If the pi index remains at same value, the runoff due to 10 centimeter of rainfall in 8 hours in the catchment is, in 8 hour storm in the catchment is. So options given are 6 centimeter, 7.5 centimeter, 2.3 centimeter and 2.8 centimeter. Two different storms occurring at different time periods in a catchment. This is storm 1. Storm 1 information is given. Using storm 1 information for the same catchment you are working out, you have to work out something related to storm 2. This is also uniform storm, this is also uniform storm because intensities are not changing. A 4-hour storm. This is T1 is equal to 4 hours. Direct runoff R1 is equal to 2 centimeter. 4-hour storm had 4 centimeter rainfall. Okay, sorry. Rainfall value given now. Runoff is given, rainfall is given. Both storms have occurred in the same catchment. Then, in the same catchment, if 10 centimeter rain occur for 8 hours, what should be the runoff component is asking. Pi index is same for both storms. Because both storms have occurred in the same catchment. Therefore, what to do? This pi index is common for both storms. Since uniform storm, so P1 minus R1 by T1 also equal to T2 minus R2 by T2. So it is 4 minus 2 by 4 is equal to 10 minus R2 by 8. So from this you can find out runoff due to second storm. On workout. 4 minus 2, 2 by 4, 0.5. 0.5 into 8, 4 it is. RT is equal to 10 minus 4, 6 centimeter. ESE question without calculator you can manage. That was the answer for that question. You know 6 centimeter. This is the right answer. Clear now? Let us try a few examples related to non-uniform storm as well. Or sometimes instead of this one, intensities also they may ask. So one GATE question, let us see. GATE 2013 this is. At a station, storm 1 of 5-hour duration with intensity 2 centimeter per hour resulted in a run of 4 centimeter, and storm 2 of 8-hour duration resulted in a runoff of 8.4 centimeter. Assume that the pi index is same. Both the storms. Question 1 is the pi index value is asking in centimeter per hour is options given: A 1.2, B 1, C 1.6, D 1.4. Second question in that, the intensity of storm 2. In centimeter per hour is A 2, B 1.75, C 1.5, D 2.25. So 2 questions are there in this. Like last question only, but here 2 things have been asked to find out. One is pi index, other one is intensity. Come on, try this question. Okay. So again, same way, same you can work out. Storm 1 occurring at some point of time, storm 2 also occurring at some point of time, both of them occurring in the same catchment, therefore same pi index for both of them. This is also uniform storm because I value is constant. Here also uniform storm I value is constant. So for storm 1 what is given? Intensity is given. Duration is given. But P is not given. So I1 into T1, 10 centimeter it is. R1 also given. So using this you can find out pi index. Therefore pi index for this storm is equal to, for this catchment is equal to this P1 minus R1 by T1. 10 minus 4 by 5. 10 minus 4, 6 by 5, 1.2. That was the answer for first question. 1.2 centimeter per hour. It is there now? This is answer. Second question, storm 2 occur for 8-hour duration. Right? Producing a runoff, direct duration result in runoff of 8.4. R2 is equal to 8.4 centimeter. Then what is intensity of storm 2 is asking. That is unknown. Okay? So if you know, same pi index can be used for this also. Duration is known, runoff is known, can't work out PE2. Okay? Same pi index can be used, which is also equal to PE2 minus R2 by TE2. So it is 1.2 is equal to PE2 is not known, R2 is given 8.4, duration is 8 hours. So from this you can find out P2 is equal to PE2. Okay, it is 1.2 into 8 plus 8.4. So it is 18 centimeter. Therefore, I2 is equal to P2 by T2. So it is 18 by 8 hours. 18 by 8, how much it is? Can work out 18 by 8 value. It is 2.25 centimeter per hour. That was the answer for second question. So I2 is equal to what? P2 by T2. This is unknown. That you have to find out because P2 is not given. So 2.25 centimeter per hour. So answer is D. So this is how you have to work out this type of questions also they are asking. Keeping pi index constant, using one storm information, finding some other storm information, resulting in the same catchment. There is a link is between the same two storms is catchment is same. So now let us solve few questions related to non-uniform storms as well. Example 7. A 6-hour rainstorm with with hourly intensities. During 6 hours, it is not raining with same intensity. Hour to hour, intensities are changing. Intensities of 7, 18, 25, 17, 11 and 3 mm per hour produced a runoff of 39 mm. Then the pi index is options given are, this is a ESE question again. A 3 mm per hour, B 7 mm per hour, C 8 mm per hour, D 10 mm per hour. Okay. So normally this type of question we work out by trial and error method. In the university exam they ask, but trial and error method we should not use in competitive exam. Shortcut we have to apply. So he is saying that its intensity keep on changing from time to time. Every 1 hour, duration of storm in hours. First 1 hour, second 1 hour, third 1 hour, fourth 1 hour, 1, 2, 3, 4, fifth 1 hour, sixth 1 hour. Every hour it is changing. 6 hours it has rained. Then I values are given in mm per hour. First 1 hour it is 7, second 1 hour 18, third 1 hour 25, 17, 11 and 3. So since I values are changing during storm, therefore it is non-uniform storm. It is non-uniform storm problem. For non-uniform storm, how to work out problem? First you need to work out W index. First you need to find out W index. So how to find out W index? By working out P. P is equal to sigma I into T. So all I values multiply with respect to time periods. So I1 into T1 plus something like that. Okay? In this question, it is I1 into T1 plus I2 into T2 up to I6 into T6. So which is equal to, first 1 hour is 7, time is 1, plus 18 into 1, plus 25 into 1, plus 11 into 17 into 1, plus 11 into 1, plus 3 into 1. So total is how much? 25, 50, 67, 78, 81. So 81 mm total rainfall. So T is equal to 6 hours. 1, 2, 3, 4, 5, 6. Sigma T this is. T is nothing but sigma Ti. Otherwise you can write II into Ti. Sigma Ti. This is 6 hours. 1 plus 1 plus 1 plus 1 plus. Okay? 6 hours are there now, 6 if you sum up you will get 6 hours. And runoff component is given to you. Losses not given, therefore we take it as 0. Therefore W index is equal to P minus R minus losses by T. 81 minus 39 minus 0 by 6. Come on, how much it is? So you got 7 mm per hour. Now we can work out pi index. To find out pi index, what require? P required. So to find P and T, neglect I values less than or equal to W index. So how many values are less than or equal to double index? This is equal to double index. This is I is equal to double index here. Therefore, this is neglected. This is taken because I is greater than double index. Taken. Again, I is less than double index. So this is also neglected. So first one, last one neglected. Remaining are taken. Therefore, P is equal to first 1 hour I value is less than double index. So equal to double index. That it doesn't produce runoff. Therefore, that is neglected. 18 into 1. Same sigma II into Ti only, but some I values we have to neglect. Neglect II values which are less than or equal to double index. Then you have to work out. So it is 18 into 1 plus 25 into 1 plus 17 into 1 plus 11 into 1. First 7, last 3 neglected because they are less than double index. So 7, 3 if you neglect it is 71 mm. 25, 18, 43, 43, 17, 60, 60 plus 11, 71. What is TE? Only 4 values, 1 plus 1 plus 1 plus 1, 4 hours. Total storm is 0 to 6 hours total storm. 1 hour, 2 hour, 3 hour, 4 hour, something like that. Understood? Storm has occurred for 6 hours, but runoff is there for only 4 hours. Zero, 1, 2, 3, 4, 5, 6. But runoff is there from 1 hour to 5 hours. During this period, I values are greater than double index. 0 to 1 hour, I value is less than double index, equal to double index. Even equal to double index also neglected. Last 1 hour, I value is less than double index. So therefore they are neglected, remaining are taken. So this 4 hours only, total 6 hours it has rained, but 4 hours only there is a runoff. So that's why that 4 hours only taken into account. Therefore pi index is equal to, it is PE minus R by T. So we already worked out P value, T value. So 71 minus same R, runoff component is same, 39 mm by 4. Come on, how much it is? 71 minus 39 divided by 4. So it is 8 mm per hour. This was the answer for that question. Understood? So answer is what? 8 mm per hour. Clear now? You have to understand. One question if you understand, remaining automatically you can work out easily. Okay, next. Let us try one more question. This is GATE 2004. The rainfall in 3 successive eight-hour period is 1.6, 5.4 and 4.1 centimeter. If the initial loss is 0.6 centimeter and the surface runoff resulting from this storm is 4.7 centimeter, then the pi index for the storm. It is not the storm, it is a catchment property. A, B. Come on, work out. C. D. Come on, try to work out. So what is given is, he has not given rainfall intensity. He has given rainfall. First 8 hours, successive 8 hours time period. Second 8 hours and third 8 hours. Every 8 hours, rainfall is changing. Rainfall intensity also changing. Rainfall means what? P values. It is given in centimeters. This is time T in hours. Okay? So, what type of storm it is? Uniform storm or non-uniform storm? Non-uniform storm this is. Because intensities are changing. But these are not the intensities. What is given is rainfall is given. So what you have to do? You have to convert this P values into I values. I is equal to P by T. So you get straight away centimeter per hour. So first I1, this is I1 is equal to 0.5 by 8. I2 is equal to 2.8 by 8. I3 is equal to 1.6 by 8. This is 0.2. 2.8 by 8, 0.35. Successive 8 hours, sorry, values are different I took, okay. One 1.6, 5.4, 4.1. 1.6 by 8, so it is 0.2. 5.4 by 8. Psi values keep on changing. What is 5.4 by 8? 0.675, 4.1 by 8, 0.5125. These are the I values. Okay. So since I changing from time to time, therefore it is a non-uniform storm. So for non-uniform storms, what we do? First we work out W index. Sigma I into Ti, the value already P values are there. 1.6 plus 5.4 plus 4.1. 0.2 into 8, 1.6 only, no? So I'll take straight away 1.6 plus 5.4 plus 4.1. 0.675 into 8, 5.4. 0.5125 into 8, 4.1. 5.4, 4.1, 9.5, 9.5 plus 1.6. 11.1, so it is 11.1 centimeter. T is equal to 8 plus 8 plus 8, 24 hours. Initial losses are given. Initial loss is given as 0.6 centimeter. Therefore, runoff also given 4.7 centimeter. So therefore, double index is equal to this P minus R minus initial losses by T. So 11.1 minus 4.7 minus 0.6 by 24. Come on, work out. Point 241. 0.2416 centimeter per hour. Actually, we are not interested in double index. Our interest is what? Finding pi index. So since straight away cannot find out pi index, we take the help of double index. So to find P and T, neglect I values less than or equal to double index. So how many values are less than double index? 0.2416. So this is less than double index, this is neglected. I1 is less than double index. This is taken. I is greater than double index taken. I3 also greater than double index. This is also considered. So the first one only neglected. Remaining two are considered. I values you have to compare, not P values. Therefore, what is P? I2 into T2 plus I3 into T3. So that is 5.4 plus 4.1. So T is equal to 8 plus 8, 16. Runoff is same. Therefore, pi index is equal to, it is P minus R by T. 9.5 minus 4.7 by 16. Come on, work out. So it is 0.3 centimeter per hour. So this is how we can work out. 0.3 option is given or not in the question? So this is the right answer. Hope now it is clear to you. So this is how we can work out questions related to non-uniform storms. Finding double index, pi index related to non-uniform storms. Let us try one more question. GATE 2007. Example 9. An isolated 4-hour storm occurred over a catchment. As follows. Time. Again he has given rainfall. 1 hour, 2 hour, second hour, 2 hour means third hour, fourth hour. 4 hours rain has occurred, each of 1 hour duration. That's the meaning. This table also given to you. Pi index for the catchment is 10 mm per hour. Options are given. Come on, try. So again, it is non-uniform storm problem. But intensities are not given. Depth of rainfalls are given. T values are given. Depth of rainfall values are given in centimeters. In mm. Sorry. So this information you have to convert into I information, which is nothing but P by T. Then you will get in mm per hour. First 1 hour. Second 1 hour, this is first 1 hour, second 1 hour, third hour storm, this is fourth hour. So each of 1 hour duration only. 1 hour, 1 hour, 1 hour. Total storm duration is 4 hours. So 9, 28, 12, 7. That's all now. So it is 9 by 1, 9 only. 28 by 1. You should not take 28 by 2, second 1 hour, that is meaning. So it is not the 2 hour storm, it is second 1 hour means 1 hour only. So 12 by 1, 12, third 1 hour is 1 hour again. 7 by 1, 7. To confuse you, he has given first, second, third, fourth. So if we divide by second, 2, 3, 4, you will go wrong. First 1 hour, second 1 hour, third 1 hour, fourth 1 hour, that is the meaning. So that is how he will confuse you in the exam. Okay, then what to do first? As usual, you have been asked to find out what here runoff you have been asked to estimate. Pi index is given. So pi index is given. To work out runoff using pi index, so I values, to find P and T, what we do? We neglect I values less than equal to pi index. So this is less than pi index, neglected, considered, neglected. Therefore, first 1 hour, last 1 hour neglected, remaining middle 2 hours we take into account to work out runoff component, because runoff is there the second 1 hour, third 1 hour only. Therefore, P is equal to, it is 28 plus 12, 40 mm. T is equal to 1 plus 1, 2 hours. Therefore, pi index is equal to P minus R by T. This is 10, 40, R is unknown, this is 2. Therefore, R is equal to 20 mm. That was the answer for this question. See the options given there. 20 mm is there or not? So 20 mm is the answer. So let us try last question. With this we'll close today. This question has been asked in GATE 2002. These are the options given there. Count or count? First day, second day, third day, fourth day and fifth day. 5 days now. First 1 day, second 1 day, third 1 day, fourth 1 day, fifth 1 day. Successively rain is occurring for 5 days continuously. 5 days it is raining continuously and successively without any gap. So it's a single stem only, but not uniform, non-uniform. I is equal to P by T. We'll get answer in centimeter per day. So whenever P value is given, immediately you have to convert into I values, because you have to compare this value with pi index or double index. Okay? That point you have to remember. 3, 8, 12, 6 and 2. So it is 3 by 1, 3, 8 by 1, 8, 12 by 1, 12. Suppose 2 time intervals are every 2 days, 3 by 2, 8 by 2, something like that. Time intervals are every 3 days, 3 by 3, 8 by 3, something like that. Okay? So your time intervals are 1 only here. Then what have been asked to find out? Value of pi index. Runoff is given as first what we do, we'll work out double index as usual. P is equal to 3 plus 8 plus 12 plus 6 plus 2. You can write sigma ii into Ti. All values you can comfortably take without neglecting anything. So it is 3 into 1, 3, 8 into 1, 3, 8, 12 into 1, 12, 6 into 1, 6, 2 into 1, 2. 31 centimeter. T is equal to 1 plus 1 plus 1 plus 1 plus 1, 5 days. So R is given as 15 centimeter. Initial losses are not given. We take it as 0. Therefore, double index is equal to so 16 by 5. So 3.2 centimeter per day. Now compare I values. So this is less than, this I1 is less than double index. Therefore neglected. I2 greater than double index, considered. I3 greater than double index, considered. I4 greater than double index, considered. I5 less than double index, neglected. Okay? So only 3 are taken into account. So to find pi index, we require P and T. Therefore, PE, to work out PE, 8 plus 12 plus 6 only taken into account, 26. And T is equal to 3 days, corresponding time. 3 days, sorry, it is in days. Therefore, pi index is equal to 26 minus 15 by 3 centimeter per day, but answer you have been asked to express in mm per hour. To convert this into mm, 10 days into hours by 24. If you multiply this with 10 and you divide by 24, then you will get this in mm per hour, 1.527. So I got 1.527. Let us see options given there are 1.53. So it is rounded to 1.53. This was the option. So this is given in the question, 1.53. So this is how You work out numericals related to double index and pi index. Okay? Hope now this concept is clear to you. Try one more question. This is ESE question. A 4-hour rainfall in a catchment. (250 km² produces rainfall depths of 6.2 centimeter and 5 centimeter in successive 2-hour time periods. In successive 2-hour unit periods. Assuming the pi index of the soil to be so it is a catchment property, soil property. 1.2 centimeter per hour, then runoff volume is runoff, how much runoff this storm produces. ESE 2015 question this is. So options given are 1.6 hectometer, option B is 16 hectometer, option C is 160 hectometer, option D is 1600 hectometer. So area into depth of runoff, work out in meters, area in hectares, then area into depth will give volume. So runoff volume you can calculate. Come on. Uniform storm or non-uniform storm? 4-hour rain is occurring for 4 hours. First 2 hours and second 2 hours. Two successive unit time periods. Depth of rainfall is given. 6.2 centimeters and 5 centimeters. Therefore, what we do? We convert this into I value. We will get centimeter per hour. 6.2 by 2, 3.1. It is 5 by 2, 2.5. So it is a non-uniform storm. Changing now. We have been asked to find out volume of runoff. Okay. Then pi index also given to you. Pi index is given as 1.2 centimeter per hour. So this I1 is greater than pi index, I2 also greater than pi index. Okay, both of them are greater than pi index, therefore both of them produce runoff. Therefore P is equal to is I1 into T1 plus I2 into T2 because both of them are greater than pi index. So it is 3.1 into 2, 6.2 plus 5, it is 11.2 centimeter. And T is equal to 4 hours, like uniform storm only it is. So pi index is equal to this PE minus R by TE. Pi index is given as 1.2 centimeter per hour. This is 11.2. Runoff is unknown. This is 4 hours. So runoff is equal to, it is 11.2 minus 4.8. So it is 6.4. 6.4 centimeter this is. So volume of runoff is equal to, so it is depth of runoff into area of catchment. Catchment area. Substitute this in hectare, this in meters, then we'll get answer in hectometer. So which is equal to, so we got this 6.4 centimeter. This I am converting into meters. 280 kilometers square, catchment area given as 280 kilometers square, 250 kilometers square. So this we are converting into hectares. Okay, that's all. This is in hectares, this is in meters. We will get answer in hectometer. Centimeters to meters by 100. Sorry, I got 1600 hectometers. This was the answer for this question. Let us see the given options. Yeah, matching. So this is how we can work out problems. I have completed this topic in every respect. So practice these problems. So almost 20 problems were solved. Practice them. One among those models will get one question in the exam. Okay. Tomorrow we'll see. We'll meet again. Timings even I don't know when they will give class. So by 10 o'clock, 11 o'clock, I come to know that what time we can have class tomorrow. Maybe possibly I'll take sometime around 8:30 to 10, 8 to 10, 9:30 otherwise. Do join me tomorrow, same place, same time, of course, same platform.